Good morning. Today we are reviewing Unit 9, preparing for the practice test tomorrow, real test on Friday. So make sure you're working on that note card. Don't think to yourself, oh, I know it all. I don't need a note card. This is easy. I've done this before. When it comes time for the test, it's super easy to make simple mistakes. That's why if you're given the opportunity to have a help sheet, use it, okay? One, it helps us remember and review stuff as we write. So just the mere writing it out on the note card helps us to review what we're doing. And two, when it comes time for the test, we are prepared for all the different questions we're being asked. So you're going to want to have note cards. So for PO66, we're talking about perimeter and area. What is a perimeter? Zelda.
The distance around the figure.
Distance around the figure, so think of fence. So you have to add up all the sides so you can figure out how big of a distance it is to go all the way around. So the fence going around the yard would be the perimeter of your yard. What is the area of a rectangle or square? So what would the definition be of area? Come on up. That is the formula. You skipped ahead. So the definition of area.
The number of square units needed to cover a figure.
Yeah, so the square units to cover the figure. So this time we're looking at our yard. Area is how much sod do I need to fill in my backyard? Okay, how much grass do I need for it? Perimeter is going around the outside. Area is filling in that middle. Remembering a rectangle has 4 sides and 4 right corners, but it's not necessarily the same length, right? So it has to have those 4 corners, 4 right corners, but it could have 2 long and 2 short. A square has 4 sides and 4 right corners, but our sides are all the same length. So a square will always be a rectangle, but a rectangle is not always a square. So now we're coming to our formulas. So the formula for the perimeter would be length plus length. It's too high. That's why it's not showing up. Let's see now. Length plus width plus width. So we are adding all 4 sides. Perimeter is adding. Important to remember. Jimena, what is the formula for the area? So perimeter is this, area is that length times the width. Notice how it's just one length, just one width. We are only multiplying those 2 sides. Okay, we are not multiplying all 4 of them, just the 2. Show me thumbs. How do we feel about perimeter and area? This is a PO because you were introduced to it last year. So if we're still a little shaky on it, you can go back and look over the homework and just kind of refresh your memory on it. So the square and the rectangle we've used a lot in our math packets. Let's look at CO67. Calculating the area of a parallelogram. Now the parallelogram has 4 sides like a rectangle. What doesn't it have that a rectangle has to have? Think about that definition of the rectangle we just talked about. What does a rectangle have to have that when we look at our parallelogram, it does not have it? Madison. Because a parallelogram has four sides. Our parallelogram has those four sides to it. Well, what was the second part, Madison?
And it has sides.
Four right corners. Four right angles, four corners. These are not right angles. We can see it's not right angles, so we know it's a parallelogram, not a rectangle. So our formula for the area, instead of saying length times width, we do base times the height. Where would I find the base of my parallelogram?
The bottom or the top.
The bottom or the top? I like that you added that, Connor, because sometimes they will give us the number up on top. They are the exact same size. So if the number is given on the top, number is given on the bottom, we know it's the base. Either top or bottom, it'll be the same number. How do I find my height? Connor?
You draw a line over to the right angle.
So it's going from one base directly up to the other base, and Connor's absolutely right. It makes that right angle. So that is my height. What if I have a slanty side? What do I do with my slanty sides? Layla? We cross them off. We don't want slanty sides. Okay? Do not use the slanty side for the parallelogram or for the trapezoid or for the triangle. No slanty sides in our areas. Cross them off if you're given it. It is extra information that's just going to confuse you. Friends at the middle table. So our base to base is the height. That straight line that makes that right angle. You only have to multiply one of the bases with the height, just like with the rectangle, length times width. We only have the two numbers that we multiply. Do you have a question, Connor, or do you want to add something? So if it's over here, yep, just like we talked about with triangles, which we'll get to, sometimes they might do this and give you your height over here. And Connor's absolutely right. That is still the height because we're going from the base to the base. They're just extending it out. They are the exact same height. So whether it's inside the parallelogram or outside the parallelogram, it will be the same number because it's still from one base to the other base. Okay. That is an example. You cannot draw the pictures. Uh-huh.
It's not like it's not really showing the shape of it though. It's kind of
As long as you don't put numbers in.
yeah, that's what I'm
Yeah, I would actually be okay with that. If you want to label, if you want to draw a parallelogram and put your base and your height on it, I'll be okay with that. No numbers.
Oh, yay.
It does pay to listen, doesn't it? Yay. Did you draw it, Sawyer? Okay. Any other questions about the parallelogram? All right, let's look at our next objective. Next, we have a PO. And this one is the triangle and trapezoid. So it is a PO. You must pass this one. So we know a triangle has the three sides. Who can tell me the formula for the area of a triangle? Ava? That's the definition of the triangle area. You are absolutely right. What is the formula?
Oh.
Go ahead, Ava.
A equals B times 8, and like over 2, and then 1/2 B times 8.
So we have two different ways we could do it. You need to decide which one makes sense to you. We could do base times height, and what does that fraction bar mean? Divide. So base times height divided by 2, or you could say a half of that base times the height. So if you're taking a half of something, you're dividing it by 2. They mean the exact same thing. So look at which formula makes sense to you and use that one, because they are identical in the math that you're doing. Just looking at the formulas, sometimes we go, oh, I'm used to this one, so I'm going to use this one. Or sometimes we go, this one just makes sense to me because I know that I need to multiply my base times my height, and then I'm going to divide by 2. Either way, it's the same math. Our trapezoid, remember, is a quadrilateral, so there are 4 sides with only one pair of parallel sides. The parallelogram, the bases are parallel and our slanty sides are parallel, but with the trapezoid, only the bases are parallel. Who remembers the formula for the area of a trapezoid? Zelda.
The formula is A equals 1/2 times B, in parentheses, B1 plus B2, and out of parentheses is times the height.
Or, just like with the triangle, we have 2 different ways. You could say base 1 plus base 2 divided by 2 times that height. They mean the same thing. You're going to take a half of the base 1 plus base 2, and then you times it by the height. Personally, for me, this is the one that I like because I need to remember to add my base 1 and base 2 and then divide it by 2 before I multiply it by the height. So I like the second one because it reminds me to add those together and then multiply, or divide it by 2 and then multiply by height. That's just my personal preference. You can use either one, whichever one works for you. So if we look at our triangle and we are given, where would I find the base? Sawyer.
On the bottom of the triangle?
On the bottom. Where would I find the height? Claire? It goes from the point, that top vertex, straight down to my base. Remember, we need that right angle. That is my height. So just like with the parallelogram, the slanty sides, we don't want. No slanty sides. We want the height going from the very tippy top straight down to the base. Sometimes we might have a triangle with an obtuse angle. How do I find my height of an obtuse triangle? How would I find my height here? I know my base is on the bottom. Where is my height? Madeline? Yeah, it's going to go outside of the triangle, just like our parallelogram. We can go straight from that tippy top point and straight over to that base extended, and we have that height. So these you can put on, no numbers. Is that what you were going to ask, Madison? No. What's your question?
So for CO71, we can't look at the numbers of like places.
I'm not on CO71 yet, hon. Ava,
Wait, but so instead of numbers, you do like A and B?
I'm sorry, what?
So you said like you can't do numbers, so could you do A and B?
You're going to want to do the variables that we have in our formula, base and height. So you want B and H, so you know where your base and your height are.
Like when we're making that price, we can't use numbers.
Did I use numbers?
No.
So that's what you should put.
Okay.
If we're looking at our trapezoid, remember trapezoid has parallel lines for our bases. And then slanty sides. So we have base 1, base 2. The top and the bottom are our bases, base 1 and base 2. Where is my height? Lilia.
When it's connecting the base 1 and base 2.
Remember, just like with our triangle, just like the parallelogram, we want to go straight down between base 1 and base 2, make that right angle. That is our height. No slanty sides. No slants. They give you those numbers, cross them off. We only need those numbers for the perimeter if we want to find how far it is around the outside. That's the only time we use the slanty sides is perimeter. Parallelogram, triangle, trapezoid, we want the height from the very top to the very bottom. So with our trapezoid, we've got base 1 and base 2. The height goes between them. Any questions on the triangle and trapezoid? Show me your thumbs. How are you feeling about those ones? How come you're back there? I'm curious. Because I did ask you to sit up front because you weren't handling yourself back there. So why did you end up back there again? I'm not sure either. Are you working on a note card?
Yeah.
Okay. I would like you to move back up front where I asked you to be because you couldn't handle yourself back there. So move back up front. All right, let's look at our next objective. PO 69. Now we're moving into circles. So, what important things do we need to know about the circle? So, what is the definition of the circumference? Connor? Distance around the circle. What is that similar to? What have we already talked about that it's very similar to, Layla? So if we look at our square or rectangle, what would the circumference be similar to? Not the area, perimeter. So perimeter is going around the outside. Same thing with circumference. It's the distance around the circle. So if you're going to put one of those cute little gardens that go around a tree and you need to know the perimeter to see how many bricks you need to go around the tree, that is the circumference. Circumference is like the perimeter. So we have two different formulas for our circumference. What is one of the formulas? Ruby?
2 times pi times radius.
2 times pi times the radius. Oh goodness, what is the radius? Layla? Yes, so our R is our radius, which is the R, and that is from the outside to the middle. What is our other formula that we could use to find the circumference? I should see every hand up. What is the other formula to find the circumference? We've got 2 pi r. What else could we have? Melanie? Pi times the diameter. So that makes me wonder, what is the diameter? The diameter we'll see as the d. What is that? Marina?
The line that goes like all the way, like from one end to the other.
From one side through the center to the other side. So our diameter has a radius going from the side to the center, and then it goes from the center to the other side. So it's got 2 radiuses in it, right? So the radius is from the side to the center, diameter goes through the middle, all the way from side to side. Kind of looks like a Star Wars little robot guy. Not R2D2, like BB-8 or something. No, it's a circle with the. That's Star Wars. Nothing. I was thinking it was the little guy that rolls around. Anyways, isn't it BB-8?
Yes.
Yes. Okay, so I digress. We need to know the difference between the radius and the diameter, depending on which one you're given as to which formula you will use to find that circumference. So you have to look, am I given a radius, am I given the diameter? And then you do your multiplication. Remember, what do we round to? We round to the 100th place. So, when we round to the 100th place, what place do we have to look at? You have to look at the thousands place. If the thousands place is 5 or higher, we round to that 100th place up 1. If it's 4 or less, it stays the same. So you have to pay attention to that. Any questions on the circumference? All right, let's look at our next one. PO70, I can calculate the area of a circle. So the area fills in that inside. What is our formula for the area of a circle? Amanda.
Pi times r squared.
So the area equals pi times r squared. So what if we're given a diameter? What do we have to do, Amanda?
You divide the diameter by 2.
Now we have to divide it by 2. So if our diameter is 12, I know my radius is 6. So 6 and 6 equals 12. So I'm going to use the radius in my formula. So it's very important to remember to use the radius, the halfway. We don't want the diameter. Any questions on finding the area of the circle? Okay. Let's look at our last one, CO71. It is important that we have all these formulas on our help sheet so we keep straight which one we use where. For our sides, our solid figures, we need to know what the face is. The face is that flat surface. We need to know what the edge is, the lines. So the edge is where the lines, the sides join. And our vertex is the point where several planes meet. So it doesn't say where several faces meet, it's several planes. So that's why in our cone, we do have that one vertex at the tip. So you're gonna want to know your definitions for face, edge, and vertex. And you definitely want to know how to classify our shapes. So you're going to want to put the cube, how many faces, how many edges, how many vertices have the cube. The rectangular prism, how many faces, how many edges, how many vertices. The triangular prism, faces, edges, vertices. The cylinder, the sphere, the cone, and the pyramid. You should have these all written out on your objective page because we did it together as a class, so I am not rewriting it. You need to write down the names of each of these solids so you can classify correctly on the test. Now you can ask your question, Madison.
So you're allowed to write like how many faces the edge.
Sure.
Okay. That's what I need to know. I didn't get all this.
Yep. Any other questions about classifying our solids, their faces, edges, and vertices? Okay, so we have practice test tomorrow, real test Friday. That means there are no retakes in class on Friday. So if you have retakes from the last test that you want to do, you need to make sure to stay after school today or tomorrow. Is there anybody planning on staying after school today? Just so I know my plans. Perfect, thank you. You're gonna stay after Thursday? Perfect, thank you. So if you want to stay after, I have others staying after. So you can stay after to get those retakes on. Some of us have a few retakes still left from the last test. Plan on staying after. If you are watching this at home, I hope you are well. I hope to see you soon. Have a wonderful day. Please make sure to get your Khan Academy done.